Hello, everyone, and welcome to our webinar series, Boosting Business Resilience. My name is Maria Sheeran, and I'm part of the marketing team here at Software Improvement Group. Today's webinar is the second in this three-part series, a series focusing on 3 critical success factors for digital transformation. And in today's session, we'll be discussing how to tackle security and privacy vulnerabilities in your organization's software landscape. Before we kick off, I do want to quickly mention and encourage all of you to ask questions at any time during the session. Just put them in the Q&A window and we'll take them at the end. All right, and with that, it is now my pleasure to introduce our featured speaker for today, Rob van der Veer. Hi, Rob.
Hello, Maria.
Hi. Rob is a principal consultant here at SIG. He established and leads our security and privacy practice. He brings more than 25 years of software industry experience to his role, primarily in artificial intelligence. And if he looks familiar, that's because he's a frequent speaker and author on security and privacy topics, and also serves as an advisor to the European Commission. So Rob, the floor is yours. Take it away.
Thank you very much, Maria, for the kind introduction. Hello, everyone. Today we're going to talk about software security, and that's an important theme now more than ever. You may have noticed that we are in a global crisis, and we need to get used to the new normal, and therefore we face increased security risks. There's a new way of working, we're more distracted, there's confusion, we're more easily fooled, and we depend more on IT than ever. And this makes us more vulnerable. I'd like to share with you some of our observations, best practices and lessons based on our research and working with clients. And first, I will take you through the typical steps organizations go through regarding software security. And that is going to take us along some of the challenges and how to deal with them. After that, I will discuss the most important lessons. And then there's plenty of room for questions from your side. Ready? Here we go. In the beginning, there was nothing. This is security maturity stage 1. We are hoping that the software we build or got is secure. We don't know because we don't test. I think many of us are past this stage. Which brings me to security maturity number 2, testing. We get some tools to do network scanning, some automated testing of our applications. And we quickly find that it's a good idea to have experts try to break into our systems using these tools, plus their own knowledge and skills. Ethical hackers doing manual penetration testing. This provides us with some good insight. However, we realize that although these penetration tests are very useful, they can only be done very late in the development phase. And that these tests only find part of the issues. Here you see a computer system visualized as a bank. Penetration testing is about trying to get in from the outside, but because you're not investigating the inside, you can miss a lot of things. For example, that the safe door is actually open, or that passwords are stored unencrypted. Because you can't break into the system now, you don't see these things. But the best thing to do is to assume that at some point people will break in. And that's why you need security to be really built into your bank and be really built into your software system. So how do you do that? Well, you need to shift left. You're probably familiar with this term. It's about starting to work on security sooner or left in the process, preferably from the start. And when you're testing, thus you have a shift left gap. Testing only finds part of the issues, provides little guarantee against breaches, and breaches lead to damages and fines. And you're going to pay a larger price if a breach reveals that the engineering was bad. I mean, look at Zoom, for example. The reason that they face so much criticism is not per se the fact that there were security issues, it's the severity of those issues. Also, because testing is late, you need to fix things once they're already done. And overhauling software is typically 100 times more expensive at the end than when you do it right away. And such rework in the final stage creates stress and rushed fixes, likely with errors, all because these test results are late. Another problem is that because no clear requirements were involved in development, the test at the end often creates a dispute between client and software makers about who is going to pay for the rework. And last but not least, if you would start worry about security from the beginning, you make sure you build in the right level and prevent, for example, that you spend too much on security features you don't need. I think these are more than enough reasons to shift left, and I hope you agree. It's today's best practice, your duty of care. Start early and seriously with security in the software development process. And that leads us to maturity 3. We're shifting left. There we go. We have security requirements, we have coding guidelines, we have training for developers, and that's all very useful and important and necessary. However, you're starting to see the pattern. Every maturity stage has a however. We realize that even if people get good instructions, we give them books, we put 400 security criteria on the wiki, we give them PDFs, they still make mistakes. It turns out they're only human. So what we need is to verify their work, obviously, which brings us to, you guessed it, security stage 4. Let's get some tools to scan the code and to detect the weaknesses introduced by developers. We need tools for code quality, for open source vulnerabilities, some SAST scanning tools, maybe different ones for different technologies. And this helps a lot. All the low-hanging fruit is found by these tools. However, the problem is still not solved. And once we realize this, we are at maturity 5. We realize that we have the tool gap, because just tools are not solving our problem completely. Surprise, surprise. They miss part of the weaknesses. 77% of OWASP ASVS, which is a large set of security checks, they are not checkable with just tools. Tools cannot see what is not there by definition, and the fact that something is not there is often the problem. Missing authorization, missing logging, no encryption, and also it's hard for tools to interpret business logic. If I ask for somebody's password and check it, but even if it's wrong and I still let users in, the tool will not detect that. These tools are hard to use and interpret. They typically overwhelm teams. Teams want to be really professional, want to build security in, but if they get confronted with a new tool, a new problem with a lot of findings that they not all understand, they are overwhelmed. Also, they need to work with multiple tools, multiple new tools at the same time, with little integration. And with using these tools, but also with making the actual organization change, because we're not talking about just implementing some tools, we're talking about organization change. They require coaching, and the organization requires guidance in how to control this whole process and this change. So this is what we call the tool gap. If you are in full swing with bridging this gap, you are at maturity stage 6. And you need to do a lot of things to be a full swing. You integrate the results from the tools in a single point of truth for developers and stakeholders. And you have experts helping with tool configuration and refinement of the findings. Experts are also performing code and design reviews, and ideally also privacy by design reviews. Plus, you have experts providing guidance to the organization in making this change and coaching the teams on building security in. This requires a lot from these experts. Security knowledge, tool mastery, coaching abilities, organization sensitivity, technology insight, code reviewability, programming expertise. Need a breathing pause here. Business context, management consultancy, and they all need to be culture changers. This is, of course, hard to difficult to impossible to find, and also hard to keep. And here you have it, today's key problem with software security. We need people to help. These people are rare, and it's hard to make this whole system, all these aspects, all these tools, all these responsibilities work well. The solution is to make it work well, to streamline the whole process in the platform, to make the whole thing very efficient and effective, so you don't need 100 experts with each 100 skills, so that you can scale. This takes time and effort to build, but it can be done. At SIG, we have built such a streamlined platform for our clients. And the idea is this. We have an integrated platform called SIGRID. It works as a single point of truth for software assurance, so for all software qualities. And it also provides a collaboration platform for teams, tools, and experts. Experts from SIG, experts from the client. Yeah.
Great. Okay, I think it's a good time right now for a poll. So we want to hear from all of you on the line. We're curious about which secure software stage your organization finds itself in. So you should see it. It just popped up on the screen. Take a second to weigh in. Maybe you're in the very early stages of just hoping or pen testing, or maybe you're starting to shift left. Maybe you're using scan tools with or without additional and sufficient security expertise. So just take a second and let us know where you're at. Rob, do you have a prediction of where you think the majority might fall here?
Based on what I see in the market, I think many organizations are working on getting the right scan tools and gaining experience with that. And some of them are realizing that they need to do more and have already hired or contracted one or two experts to start with. I think that's the majority of where people are right now.
Mm-hmm. Excellent. Okay. Well, it'll be interesting to see if you're right. We're still waiting for the results to come in here. Up. Here they are. And it looks like most people are in the kind of just pen testing phase. A few others, the majority are in that phase, followed by the kind of we're just using the scan tools and we think we're okay. So interesting there to see the results.
Yes, that's very transparent. By the way, the results are anonymous, so don't worry that we'll share this.
Indeed. And
Yes.
now that we have a better idea as to where all of you are in terms of building secure software, Rob, can you share some tips and tricks on how to succeed in shifting left and bridging the tool gap?
I'm glad you asked. In our work with clients and in our research, we found out that software security is hard. Defining the target state is easy. It needs to be secure, so it needs to follow these rules. But getting there requires many steps with many pitfalls. It's about everybody. Everybody should own the problem. If you make security if you polarize the discussion, if you make it sort of a tug of war between business and IT, you will fail. The business needs to own the importance of security and its effects on the business, typically on the midterm to longer term, the risk for breaches. Bad attention to software quality will bite you in the end. This needs to be the vision of the organization, and therefore product owner management need to own security as a business goal, and then it becomes a collaboration. Also, we've seen that developers learn best when they get educated based on their own code. Every development team is different. What works best is that when we do workshops with teams, we show them the source code, their source code, the things that we found in the source code regarding security, privacy, and there are things that they do well, and there are things where they have blind spots. For every team, this is different. So it's important when you train teams to take into account the way they work right now and reflect on it as part of their training. Also, it's important to not bet on developer memory. After all, we're all human, also developers, they're all also human. You want to make the list of requirements that they need to work with constantly as small as possible. And you can do this by having them build on proven technology so that they take care of a large part of the security requirements automatically because they're using framework X. It's important to filter the requirements that they use situationally, and have some pointers later on about this. And it's also important to teach them not on the details and ask them to memorize it. Of course, you can use details to illustrate, but the importance is in getting across the principles to the developers in their training instead of discussing 100 types of detailed security weaknesses and vulnerabilities. So don't bet on developer memory. Code quality. Talked about it earlier. It's a similar challenge and also a prerequisite for security. It's hard to measure. You can't see it from the outside. It's non-functional. It requires a feedback loop, a short feedback loop, actually. It requires a dashboard. It requires governance. It requires control, just like security does. So the best security program is a security program that is integrated with the general code quality program. And the same actually goes for privacy. It also fits well in such an integrated approach because it is about principles, it is about requirements. Privacy is not just for the legal department. Developers have a very large influence on privacy issues in systems. You can easily introduce very big privacy issues. And once there's more control over this, you can manage this problem also as part of this integrated program. As said, shifting left by adding tools has a high risk of failed adoption. This is because you bring in this new tool, everybody's excited, but then they need to learn to use it. Then it's sometimes quite difficult. The tools don't explain it really well. There's many false positives, things that these developers need to sift through. So it's very important for the success of the adoption of these tools to provide intensive guidance for these developers in using these tools. And these tools, it's important to realize that they only find part of the issues. So it's essential to have manual review as part of your process. Manual review by other team members, by security professionals. Code review is difficult, it's hard. You need specialists for this, especially to do this incrementally. So make it part of agile sprints, for example. Making them incremental requires special expertise. This is something to take into account. And last but not least, do not focus on new development only. So when you are shifting left, you want to increase the level of security in your software. But it's important to realize that there's a lot of software that you already wrote, that you are maintaining. But there are weaknesses in the software, as illustrated by this iceberg. So the tip of the iceberg is the software that you're new developing, and you're in full control of security there. But the software that you already developed, that is running in your business, may be filled with vulnerabilities and weaknesses. And when you want to increase your security posture, it's important to do more than just security and privacy by design for your new development. Now, I want to end with giving you some pointers, some work that I have been involved in also. First, it's the Dutch CERT, the NCSC testing white paper. It's a white paper that discusses the importance of having different types of security verification, like, for example, penetration testing, like, for example, code review, vulnerability scanning, and it describes how you can put these different types of verification into practice. It's been recently released, and I was one of the people who contributed. Also, I was co-author of a NISA report that coincidentally was released last week. It's a report called Advancing Software Security Through the European Certification Framework. If you go through this, it will provide you a good overview of different security standards and how they are related. Standards about the development process, but also standards about technical requirements. And talking about technical requirements, I personally like and use a lot the OWASP ASVS. It's been updated constantly by the community for the community. It's a large set of verification checks for web applications, but also for other types of applications. There's a special version of it for mobile applications called the MASVS. And if you're looking for a smaller set of requirements, with more structure and some guidance. There's a new release of the GRIP on Secure Software Development Standards version 3. There's a Dutch release candidate available. It's being translated to English. It's a more concise overview of security requirements that you might find helpful in making sense of all these standards. Because one of the conclusions of the ENISA report is that there are many, many standards, and it's hard for these standards to be effective in their use. It's hard for developers, procurement, testers to find the right standard for the right situation. There are different viewpoints from different standards. There are many to choose from. There are some gaps. There are some quality issues back and forth. They do not align. So this results in a situation where software makers need to work according to different standards where there could be alignment, so they can more standardize their way of working and be much more effective and systems much more secure. I'm working on an initiative called the Common Requirement Enumeration, CRE, as part of an OWASP project that is going to link different standards together. So we're going to work with, in first instance, all the standards as part of OWASP, so the ASVS, the testing guides, the MASVS, the controls, the cheat sheet. We want to link them together using a ID that links similar things together. And this link will make it easier for people to find the right information from the right perspective. And we want to extend it towards other standards in order to find more alignment between standards, but also make it easier for standard makers to maintain their work, to align their work, and to refer to the work from others instead of trying to incorporate it into the text and get out of scope. So that's work in progress. There's a link there if you want to keep an eye on it. Then there's making requirements situational. How to do this can be found in the Agile notes that are in addition to OWASP-SAM, which is a recommended standard for the software development process. It works great if you want to improve your software development process. If you want to know where you are, there's a recent new version, and it will help you to mature from stage 1 to stage 7. And that about sums up the final things I'd like to share with you today.
Excellent. All right. Well, we've certainly covered a lot of ground here. So now let's go back to you all on the line and see what questions have come up for Rob. I see a couple here. Rob, let's take this one first. This person is asking, you talk about situational requirements. How does that work?
Yes. So the idea is not to bet on the memory of a developer and make it easy for developers to build security in. And that means that if they're doing a specific type of task, like they're working on a specific user story, is that they only need to focus on a small set of requirements. That's what I mean with situational requirements. And you need a mechanism to select the right set of requirements for the right type of work. And we call that triggers. So it's mentioned in those agile notes that I referred to at the pointers. It describes a process where the security requirements that need to apply to a system they get triggers. So you need requirement X in situation A and requirement Y in situation B. And then when you are preparing the work for developers during refinement and you're building your acceptance criteria for your story, you can look at those triggers, find the right requirements with the right type of work that the developer is doing, so that the developer can focus on those, and that testers also can focus on those, and that it's not asked of them to remind 100 things at the same time.
Great, thanks. Okay, let's go to another one. Why is rework 100 times more expensive?
There's actually research done for this, which indeed comes with this number 100. It's the difference between doing something right in the first place and having to fix it at the end of development. And this is because if you're building something into software, you're building something on top of it, which depends on it. And you're building something on top of that. So you're layering actually a change, a decision, and make other things depend on it. If you need to change that decision because there's a security weakness involved, for example, the way you are authorizing different systems and users to get access to functions is not good, well, then you need to also change all these dependencies and do the tests all over again. It would have been much better if you would have applied the right security requirements at the moment that you made the initial decision. So that's what's being meant with 100 times more work.
Great. Rob, thank you for all the insight shared today. That wraps up our session. Thanks to everyone for joining us today. As mentioned, this is a 3-part webinar series, and we'll be back for our 3rd and final session next Thursday, May 7th at 10 a.m. Eastern, 4 p.m. Central European Time. The topic next week will be how to effectively modernize your organization's software landscape. We'll send all of you a follow-up email here shortly with the link to register for that session. And that email will also include a recording of today's webinar. So feel free to either rewatch it or share it with any of your colleagues who may have missed us today. And as always, if you have any questions at all, please feel free to contact Rob directly. You can see his email address right here on the screen. All right, well, thanks everyone so much once again, and have a great rest of your day. Bye.